Welcome to another video on smart architectural programming. And this video is video number 3 of the UV Python Houdini playlist, in which we'll be delving deeper into Houdini and how to leverage that for UV Python related tasks. Before we get into the main aspect of this video, which is procedural workflows, which is basically the next topic of this video, let's focus on basically asking you to like and subscribe our channel so that more people like you are able to access and learn from the materials that we publish. So without any further ado, let's push forward and start this video. All right, so let's talk about the first thing on Houdini's practical side, basically, before we get into the more specific methods of how we're going to create those certain scenarios, right? So first of all, remember that Houdini is basically a Swiss Army knife for 3D modeling, right? And there are different reasons as to why you want to use Houdini as such. Number one is procedural workflow. So you need to, it helps you in saying goodbye to manual tweaks. Houdini is basically built on procedural nodes, meaning every tweak is non-destructive and repeatable. So again, keep in mind, this video is more so for people who have some experience in UV Python and related to 3D modeling and game development. So keeping that in mind, I'm probably not going to go into too much basics, so I'm just moving directly towards the more technical sides of these things. So generally speaking, when you talk about procedural workflow, a procedural workflow involves creating 3D content through rule-based systems and algorithms rather than manually modeling or sculpting. In Houdini, this means you define processes and behaviors that generate and modify geometry, simulations, and animations. These processes are encapsulated in nodes, which are the building blocks of Houdini workflow. So, nodes are the core building blocks in Houdini, as Houdini is a node-based architecture, where each node represents a specific operation. Nodes are linked together to form a network that defines a procedural system. There are different types of nodes based on their function. So basically, I'm just going to go over some of those nodes here. SOPs, which are surface operators for geometry creation and manipulation. DOPs, which are dynamic operators, basically for simulations like fluids, cloths, or rigid bodies. VOPs are vex operators, which are for shader and attribute manipulation using visual interface. COPs are for compositing operators, which are for image and texture processing. CHOPs are for channel operators, which are for handling animation, data, and motion effects. So when we're talking about procedural workflow, the next important aspect that you need to understand, you can look at the screen right now. I'm showing you basically some of the forms through which you can see basically on side effects, where you can go and see and understand which procedural workflows and discuss with the community basically. But otherwise, just getting a general understanding through my conversation, it would give you an idea of how Houdini's node-based procedural workflows work basically. So there are certain advantages to Houdini's node-based architecture for workflows, which basically are very important as to why we're going to use Houdini. Number one, it's a non-destructive workflow, meaning that each step in the process is stored in a node, allowing you to revisit and adjust earlier stages without actually starting over the entire 3D modeling process. Then it's very, very reusable. Basically, once created, procedural setups can be reused and adapted for different projects. Then there's scalability. So procedural systems can adapt to changes in input data, making them suitable for large-scale environments or iterative projects. And number 4, automation. Tasks like creating forests, cities, or complex simulations can be automated through procedural rules. An example of a procedural workflow, I'm just going to give you a very simple scenario for this basically. An example of procedural workflow is generating a procedural building. You create a basic shape, use a box node to define the basic building dimensions. Then you add details, use nodes like poly extrude to create windows or facades. 3, you randomize variations, which is add attributes, heights and width, and manipulate them using vex code or procedural tools like attribute randomize. And then you generate instances, use copy to point, scatter multiple variations across the grid. Then you finalize by adding shaders, materials, and lights procedurally using VOPs or predefined tools. Then we have basically the next aspect of procedural workflows is basically attribute-based control. Attributes are a key part of Houdini's procedural system. They allow you to control almost every aspect of the workflow. Basically, there are two types of attribute-based controls that you need to focus on initially. That's geometry attributes, which are position, normals, and UV coordinates. And then you have custom attributes defined by the user for specific tasks such as density or temperature. These attributes can be manipulated mathematically, providing fine control over geometry, simulations, and effects. Then we need to understand digital assets basically. So basically Houdini allows us to encapsulate procedural networks into Houdini digital assets, HDAs. These are reusable tools with customized parameters, enabling a high degree of modularity and collaboration across projects. Then we have integration and simulation and digital assets in procedural workflows. Basically, they're extended seamlessly to simulations by creating. You can create complex particle effects, destruction sequences, or fluids dynamically, and you can modify simulation parameters procedurally to adapt to scene changes. So there's certain real-world applications to this as well. Basically, film and VFX. Procedurally generated destructions, explosions, and environmental effects are created using this. Then their game development, modular asset creation for large-scale environments. Then their architecture visualization, procedural modeling of cities, interiors, and landscapes. While there's a lot of good things that I mentioned about procedural workflows, there are a lot of challenges as well. That's why there are other systems out there for 3D modeling as well, equally as powerful. Which basically the complexity of node networks is a major challenge in Houdini, as well as the steep learning curve for understanding Houdini systems and scripting languages like Vex or Python. So basically that's how procedural workflow works, and we're going over the main concepts in step 2 of this video. So those are important things for procedural workflows that we need to talk about. So let's move on to the next thing we need to discuss in this video.